Welcome to Maths Concepts. So what I'm looking at in this video is I'm looking at geometry. And the aspect of geometry that I'm looking at is actually dealing with a perpendicular bisector in the triangle, right? Or we could solve problems surrounding that. Here goes. So, so as you can see, we're supposed to find the value of x and y, right? Now, the conditions that we have, as you can see, we're looking at triangles over this side, right? So what stood out is the fact that this line segment here actually is a perpendicular bisector of this line that, as you can see, the notations are on the line that suggests that the two lines are of equal length. So the perpendicular bisector, as you could see, cuts this line into two equal pieces. And because it did that, we have enough information to solve a problem. Because when a perpendicular bisector cuts through a triangle, it's going to create congruent triangles. For example, because of the perpendicular bisector, which is this line here, right? What's going to happen is that this triangle that I'm going to highlight in pink is going to be congruent to this other triangle that I'm going to put in green. It's congruent to it. So those two triangles are of the same measurement. Now, how could I use that to solve for x? Now let's take a quick look on this idea. All right, let's think about this. This green side is going to equal to this pink side here. Both of them do share the same perpendicular bisector. So this is a side for both triangles. So you could see that if the green side is the same thing as the pink side, and both of them share that blue side, it means then that both triangles would actually be sharing this same length here. This one in yellow would be the same thing as that one in yellow. So on that basis, we could do this. I could take that out, and now I could say, guess what? 2, open bracket, 3x plus 1 is equal to 9x minus 10. I am able to take them and equate them because the perpendicular bisector did create congruent triangles. So I could use this to solve. I'm going to distribute this 2 inside the bracket there. So I'm going to have 6x plus 2, which is equal to 9x minus 10. I'm going to collect all my x's on one side. So I'm going to migrate this to the right side. So I'm going to subtract 6x from the left side, which means that I need to subtract 6x from the right side for balancing. So if I break this down and take a look, I'm going to be left with 2 on the left side, which is equal to 3x, then a minus 10. The intention is to have the x's alone, which I need this to be by itself. So I'm going to have to add 10 to both sides so that the 10 can be canceled out on the left side, on the right side. So I'm going to have to add 10 to the right side. On the right side, I do have 12 by this time, which is equal to 3x. I don't need 3x. I only need x. So I'm going to divide both sides by 3, balance the equation by dividing the other side by 3. 3 into the 12, 4. This is telling me that x has a value of 4. So right now, x is equal to 4. All right, so we were able to use the congruent idea there, linking the perpendicular bisector to the triangle and making sure that we get that out. All right. So let us take a quick look at the other solution. Right, let's go. All right, so it's my intention to solve for y. Now let's look to see what's going on. In blue, take a look at this triangle here. It's a very small one. This triangle, we're going to focus on it. All right, so if we focus on that triangle, right there. We're going to notice, though, that same perpendicular bisector, which is this line, it did cut through it as well, and it comes to the vertex right there, right? So we're going to utilize that to help us to understand what happened with the triangle. Take a look here at the sides I'm going to highlight. This green side here is the same length as we had already been discussed. So those are the same. Again, they both share this perpendicular bisector here. So you could see that there are two sides of the triangles that are the same length, the same angles there. So that means those two triangles are congruent. So the final thing that we could say is that means that this side here, 3y minus 1, is the same as 2y plus 3. And on that basis, I'm able to take this value and equate it to this, or this expression, and equate it to that one. So let's write them down. I could take 3y minus 1 and let it equal to 2y plus 3. Just a reminder, I could do that because I realized that both the triangles are congruent, and those are corresponding sides, right? So let us say I solve, I want to take 2y from that side, I'm going to minus 2y from the other side. So on the left side, I'm left with y minus 1. This is equal to 3. In an effort to solve for y, I'm going to get rid of that negative 1, so I'm going to add 1 to both sides. So y is now equal to 4. This is 4. There you go. And those are the solutions. So the conclusion is, when we have a perpendicular bisector in a triangle, it's going to create congruent triangles, right? So with that, with enough information being given, we will be able to work out stuff. All right. Thank you for watching Daily Maths Concepts, and see you another time. Bye-bye.